Hi, this is Scott Beattie. Welcome to my YouTube channel. Today we're going to be exploring the relationship between space, time, distance and the Earth's rotation. Okay, for the purpose of this explanation, imagine that this is a scale model. The cardboard cylinders represent the North Pole. Here they are there. The Sun, which is over here, is its actual size in relation to the Earth. As you can see, it's actually smaller, but I've had to draw it like that for the purpose of this explanation. The Earth is no longer orbiting the Sun. Okay, the Earth has no axis tilt of 23 degrees. Everything is static in the solar system except for movement between Benjamin, this guy over here, and point A, except for the Earth rotating on its axis in scenario B and C. The Earth is the only astral body in the solar system that is moving. The Earth is rotating in an eastward direction, so over here I've got the arrow indicating that it's rotating in an eastward direction. This is why the Sun rises in the east and sets in the west. Greenwich Mean Time has been used. This is a hypothetical scenario to explain the relationship between space, time and distance. Okay, as you can see here, if you're looking down on top of the Earth with the North Pole, the reason why I've divided the Earth into 24 parts is because there are 24 hours in one complete day. So this here is like a 24-hour clock as well, whereas these divisions here, I'll explain it. So I'll take that away to avoid confusion. But if this little marble represents Benjamin, and say it's midnight and the Sun's over here, obviously it's dark. But as the Earth rotates on its axis in an eastward direction, there's 1 AM, 2 AM, 3 AM, 4 AM, 5 AM, 6 AM. So obviously at 6 AM we've got the sun rising in the east. Okay, it's just breaking into morning. 7 AM, 8 AM, 9 AM, 10 AM, 11 AM, and then, this keeps moving, 12 PM. So obviously it's 12 PM now. The Sun's directly overhead, over the top of Benjamin. It's called midday. And we've got 1 PM, 2 PM, 3 PM, 4 PM, 5 PM, 6 PM. Okay, so the Sun's now setting in the west. We've got 7 PM, 8 PM, 9 PM, 10 PM, 11 PM, you keep slipping, and now we're back at 12 AM, so that's midnight. Okay, alright, so what I'm going to do now is I'm just going to remove this, and we've got Benjamin over here. I'm going to put my 24-hour clock back here, and we've got point A over here. Okay, so for the purpose of scenario A, I want you to imagine that the clock has stopped rotating on its axis. So we're going to make point A 1 kilometre over here from Benjamin. So obviously, as 1 hour passes from midnight to 1 AM, Benjamin moves 1 kilometre to point A. So obviously over the time of an hour, he moves 1 kilometre, so he's travelling at 1 kilometre per hour in an eastward direction. Alright, here's the other scenario. He's 1 kilometre over here, away from point A. So from midnight to 1 AM, he moves at 1 kilometre per hour to reach his destination at point A. That's the first scenario. Now, I know you're probably wondering where I'm going with this, but it will make sense towards the end of the video. Alright, scenario B, I'll just move this. Here's scenario B. There's Benjamin there, okay, and there's point A here. Now, what I want you to realise now is the Earth stopped rotating, but the Earth is going to be rotating on its axis, but Benjamin is not going to move. But notice where point A moves to. So we're going to use our 24-hour clock over here. Now, from midnight to 1 AM, okay, you're going to see the Earth rotating on its axis. And what you'll notice Okay, Benjamin hasn't moved, but if you think about it, point A in the solar system has moved. If you think about in the relation to everything else that has remained static in the universe, that point there has actually moved in the cosmos. Okay, so we'll do it one more time just to show you. So Benjamin's not moving. He's just he's stationary, and then as you can see, as 1 hour passes, point A has moved. Even if we look at it over here, okay, Benjamin's still 1 kilometre away. Over 1 hour passes. He's moving in a westward direction, but he hasn't moved towards point A because he's remained static. And obviously point A has now changed its position in the universe. All right, here's where things change a little bit. Here's scenario C. Benjamin is 1 kilometre away from point A. Now, as time passes, here's the key. As he moves towards, from midnight to 1 a.m., as he moves towards point A, the Earth is rotating on its axis. So he's travelling at 1 kilometre an hour. So the question is when Benjamin travels at 1 kilometre per hour, as the Earth is rotating on its axis, is he travelling faster at the same speed or slower than when he was, was he travelling faster, slower, or at the same speed when compared to the Earth not rotating on its axis? Okay? And the same if you look at it if he was travelling in a westward direction, all right? So over 1 hour, he travels in a westward direction, but he's walking against the Earth's rotation. So over 1 hour, he's still moving at 1 kilometre per hour, okay? But as you can see, that's the speed he's moving at is 1 kilometre an hour, but is he moving faster than what he was in an eastward direction or a westward direction? All right, here's scenario C. Here's the questions to consider. When Benjamin travels towards point A in a westward direction at 1 kilometre per hour, is he actually travelling faster, the same speed, or slower than what he was when he was moving in this direction when the Earth wasn't rotating on its axis? Has he travelled the same distance during this time? Has the same amount of time passed when he has travelled towards point A in a westward direction? So the key here is, this is the ultimate question. If you were Benjamin and you wanted to get to point A fastest, would you travel to it in a westward direction or an eastward direction, given that the Earth would be rotating on its axis? So I'll do it to try and sort of summarise this whole clip. If the Earth's rotating here, notice that Benjamin is moving with the Earth's rotation in an eastward direction, whereas if he moves to point A from over here, he's moving against the Earth's rotation, okay, but he's still supposedly travelling at 1 kilometre per hour. So what is the relationship here? How does that affect the speed that he's travelling at? Has he travelled the same distance? Has it taken him the same amount of time for him to get from where he is here over 1 kilometre to point A when the Earth's travelling in a westward direction, as opposed to when he travels from over here to point A in an eastward direction? Thank you. I've tried to make that as clear as possible. I know it might be a little bit hard to understand, but I'm just trying to explain my understanding of the relationship of space-time, distance, and the Earth's rotation. Thank you very much.